So one more thing, just based on a question, which meant I probably wasn't all that clear. As far as I understand, I don't think kubesys offers you, more protection or more API access. I think it's more just meant as an umbrella to make it clear to the administrator this is part of the system. Though there are scheduling things coming also, scheduling features for priority and preemption, so that you can mark certain pods and say these are higher priority than others, and that these can preempt other pods at lower priority. And so if you're looking to say that you have pods of your own that you want to make sure are going to run over other pods, there's a whole ton of work going on there. And I believe that you look at Bobby Salamat or the SIG scheduling team, you should be watching what's going on, especially for many of the people in this room, where someone just brought up from Red Hat how he's got a pod that he wants to make sure is always running. Like, that's the best way to do it. And that's alpha in 1.8, and you can play with that now. And so that's all. Sorry about that.
All right, taints and tolerations. Is everyone familiar with how this works on other parts of Kubernetes? No? Okay, so if you have a node, it may be tainted with some value, and then you can have basically have actions that your pod takes if a node becomes tainted, such as evacuating it from the node or giving it some time to let the node recover. The basic format, let me tell you, I don't understand this 100% myself, but I threw this together 2 days ago, so we'll see how it goes. So the basic format is you would taint a node with a value, and then you would have kind of a logical selector on your pod that says what to do if that value is encountered. And then you'd have an effect, which would be the action to take if the toleration is met. So the idea for storage would be you would taint your PVs. You would give them some kind, or a PV would become unhealthy. It would become slow. It would have some kind of performance degradation. Maybe it's having trouble attaching to the node. Something happens to the PV, and we want any PVC that's already bound or any application that's using that PV to be able to come into some kind of recovery mode, take some kind of recovery action for it. The most obvious case is if the PV becomes unhealthy for some reason. If we have Gluster and one of the bricks fail, Gluster is going to slow down and it's going to have to go into some kind of recovery state. We may actually want to move one of the or the Gluster service to another node that would have healthy storage on it. But I think the concept can be abstracted a little bit further than that, and we could actually use this for quite a few other things. Is that a pretty good overview? People kind of understand word? Okay. So this is completely all straw man stuff. Feel free to pipe up with goals or non-goals. And then I'll just kind of go over this design doc or this straw man design. So goal, provide a means for PVCs to avoid binding to PVs with certain taints. So a PV could be created with a taint before the PVC is actually bound to it. And we'd want the binder not to bind the two if the PVC doesn't tolerate that particular taint. If a PV of a tainted PV. Yeah, so the way I was thinking about it is maybe you had a GID, maybe you had a brownfield PV with some data on it that had a specific GID range, and you only wanted PVCs that had whose user fit that GID range to bind to it. So you may taint the PV with, say, you only allow GID ranges 65, 650, and then a PVC would have to tolerate that GID range before they would get bound. It would be one way of preventing PV and PVCs from binding if they didn't support the security.
What about
issue that we were talking about handling that with the selector? Yeah, you can use label selectors or storage classes
Yeah, yep,
to do the same thing.
yeah, you can.
What was it? I mean, I remember talking. Sorry. I remember talking about this a long time ago, though, about having these type of selectors within a storage class to better define characteristics of that class. So like I want it in this particular zone or name or anything like that. I mean, is that similar to what you mean? So you can create a better filter of what you want to bind to?
Yeah, or I mean, so you may have like a slow PV that's not necessarily in a storage class. You just know that it's slow. It could be tainted as slow. And then you have certain pods that tolerate it being slow or.
So I was, my understanding was that PV taints and tolerations would really come into use for marking the health of a volume. So if you have properties of a volume which are predetermined, they're fairly well captured by storage class and the selector mechanisms and everything that we have today. But after a volume is up and running, there are things that can go wrong, which make the volume no longer healthy. And it sounds like taints and tolerations, that would be the primary use case.
Well, so what happens if you go further in the use case and you're looking at a volume that was in use and now it's unhealthy, and whatever application or whatever PVC was bound to it says, I don't tolerate that, rebind me to something else. So now we have a PV that's tainted as unhealthy, and maybe we have a health check or a cleanup pod that could come in and tolerate the unhealthy volume.
I think there's some
recovery action on it.
There's some potential here, right, for like administrative stuff, right? So users in namespaces have no access to PVs, only PVCs, right? And through dynamic provisioning, they can create PVs, associated with their PVC, but they still can't access or do anything. So I think, and then there's always the old school manual creation of a PV for things that don't have the service interface to do create and delete. So you can imagine in the old school example where an administrator is manually creating PVs and the storage system, they're supervising it and they notice that a disk is bad. They could go in and taint certain disks, like the storage administrator could go in and taint certain PVs. And then the system could do something about that. I think in another case, even when they're being dynamically provisioned, one might consider that, I know we do this for OpenShift Online, right? Like we have all these different projects and users, but there's still an OpenShift Online administrator that sees all the PVs, right? And like the health and stuff in EBS, and like is doing like, backups and things like that. And I think there's a potential, even with dynamic provisioning, to have a sort of someone looking at the backend storage and helping users by flagging when things are gone haywire. I'm not totally sure what would go haywire in that scenario. Like rotational media goes bad all the time. There's a mean time between failure that's known for that. So, but those are two scenarios I can think of.
Network partition.
Sorry?
Network partition.
Sure.
But I guess the part that is not clear to me is, so right now PVCs and PVs, they have phases, So if like they can be lost, pending release, whatever, we can potentially use those fields for signaling something is not working. But what's not clear to me is what's the corrective set of actions we can take once we detect that something is not working. Because once the PVC is bound to a PV, that's it. Unless we create a new PVC and a new PV where the new PV points to the same storage, I don't see any remedy for going around the problem.
The Kubernetes tainted PV controller.
Well, so all right, another interesting case might be snapshotting. So if we snapshot into another PV and the snapshot's ongoing, or the volume we had a problem before where people were depending on the phase to determine if a volume was actually available or not, and that wasn't a real good indicator of the volume actually being available. So, I mean, you could, in theory, probably, even if it's a newly created volume, have it walk through different taints of availability, like volume creating, volume created, volume, disk formatting, or snapshot underway, snapshot finished. I don't know. I mean, we can take this out of the high-level goals. This is
another problem is also like most of Kubernetes storage components, these are control plane components. They're not data plane components. You don't necessarily know whether IO is going to backend or not. There is no means of measuring, whether something is healthy or not. That's another problem.
This like an active request from a customer that this would be like, I know we've talked about it in the past, but where does it originate? What problem does it solve? I mean, since we can't do a cleanup, we can't just kill that PV and allocate another one and possibly lose data. What does it solve? I guess it's
there is no point for this, if that's what you're at. This doesn't come from a customer.
So the main motivation that I had for suggesting this feature is to support the local storage use cases of the distributed storage systems, because once you are bound to a local disk, your pod always has to be scheduled on that node. But if the node dies or the disk fails, then your pod is stuck and cannot be rescheduled. And for most of these distributed storage systems, they can handle node or disk failures. They should be able to release their volume and get a brand new disk and recreate their data from the replicas.
And so, I mean, there's a lot of help.
it's that one that it would stay active. It wouldn't die. So even if you had, a daemon set or something that said I needed 4 versions of it, you're saying the pod wouldn't restart and attach to the volume on that particular node,
Yeah,
right? It would
because once for local storage, you're really limited to just that node.
right.
But then the applications that want to use local storage, they should be able to tolerate node failures.
Makes sense.
And that's on the application.
Right.
The onus is on the application.
Correct.
Could the existing taints and tolerations on nodes be reused for this, or does it necessarily require a new taints and tolerations on PVPVC?
So you can have multiple disks on a single node, right? If you taint a node, how do you know that the disk you're using is the actual one affected?
Did you make the taint name be correspond to the volume?
What if more than one volume?
Like,
You have multiple taints?
How does that work, Michelle? So because often in failover with a distributed data management platform, right? Like you got, say, 6 servers, 6 pods, each one running on a different node, each one using local disk. And then usually the scenario is node 1 goes offline. Like someone pulled the power out, or something happened with the network or something, the whole node goes offline. And so in that, the scheduler would pick that up and schedule a new replica and business as usual. I think in this case, what we're saying is node's still online, but disk has gone offline. How do we identify, how do we sense that? That a disk has gone bad? I don't in Cube.
I don't think, so that's very hardware dependent. There's no one way to do disk health checking. So it needs to be some external plugin that is tuned to the exact hardware on that node.
Basically run an add-on, and then when it's I wasn't trying to be funny there. Have something that's checking the health of the disk. When it identifies something, it can taint it, and then basically, what do we do? Do we
The controller, the PVC taint controller will figure out if the PVC can tolerate it or not. And if it exceeds its toleration threshold, then the controller has to unbind the PVC
Okay.
and then evict the pod.
Unbind the PVC, evict the pod, and then it just, stateful say business as usual.
Yeah.
Right. Okay.
Or it could be pluggable. I mean, the execution could depend on what the taint is. Like with our EBS attach failures, maybe we want to taint the PV that the EBS, attach failed on it, and the recovery action is to detach it and provision another EBS device. So we may have like an AWS specific taint and recovery action, in the health check for that.
And Steve, like a practical example, and I've been doing CSI for the last 2 days, so might as well keep on down that track, right? If we've got Dell servers, for example, and they're going to have specific hardware inside of that, like we would have a CSI block devices plugin, which has specific management capability into our local devices, our local disk drives that we know about and how to understand and figure out status codes and stuff. CSI doesn't have it today, but we'd be reporting that type of information up through the CSI plugin. And then I would assume it would land in the volume plugin infrastructure at that point to say, hey, status code on whatever volume that came in is bad. And then that would make it up in the taints. Like I see the path in terms of the use case you defined, all starting with like something like the CSI plugin. If you're talking about external components like drives that differentiate by vendor that need to be understood.
Seems like this could get out of hand.
What do you mean? Mic the guy up. Give him a microphone. What's the?
No, I think that, you start adding in all of these.
The more of these levers and hooks and everything else that you add into this, I think you're going to run into some serious issues maintaining this going forward.
How so? What do you mean?
Well, so for example, let's take the example Clinton just talked about, right? So he's got Dell servers with specific drives. Each of those drives may have different codes and different meanings and different recovery processes. So that's just his specific case. And then add in the AWS cases, and then the OpenShift cases, and then the NetApp cases.
Well, we wouldn't own that as a community. Like as a vendor, he would own that, and he would distribute that as value add to their server sales, right? Like
the Dell server CSI plugin for local block devices.
Right.
And then like in CSI, there would be a status indicator on like a list volumes call, right? And then the list volumes through Kubernetes, like it would take status, and that's what it would figure out if it needs to apply to different volumes. So
be one of the things that come in the the motherboard box when you get your server, like one of those disks, right? Like your taint health check for Kubernetes.
Yeah, I guess. So that makes sense, and I get that, and I guess that should definitely be something that people could do and leverage if they want. But I think at some point when you start trying to do under the covers, like the word heal is my least favorite thing to ever see, right? Because what is that? What does it mean? And how do you know you're doing it right? And how do you know as an operator or as a user that something is wrong? Right. When you start doing things under the covers, I think
So it's always going to be storage dependent, right? So whatever storage platform you're using, it's going to have probably a different health check. If it's local storage, it might just be an FS check that you run on the disk, or it may have some status code that you can monitor with some different software. If it's AWS, you may have to go, through some CLI tool to see what the status of the disk is and monitor its health that way. Right. So my goal, I don't think the goal of this should be to like solve health checks for every volume type and tree. Is just to provide the framework so vendors
for somebody to do something.
Yeah, so they can provide taints for their stuff and also ways to recover from it.
Yeah, fair enough.
So let's talk through what this would look like concretely. You've got PVC and you've got PV. The taints would go on the PV, tolerations would go on the PVC.
Correct.
A taint would, for example, would be unhealthy. So some component, it could be external, decides that a particular PV is unhealthy, and it updates the PV object with a new taint to indicate that it is not healthy. Nothing happens immediately, but there's some other component which is
It could be like the external provisioning controller that sits there, watches for
monitoring
PVC
PVs.
actions, says, does this toleration match this taint? If so, I'm going to take action.
So you're going to have something sitting there watching PVs, and if it notices any PV with an unhealthy toleration, it's going to unbind it.
Well, it
If
depends
a certain
on
amount
your
of time.
recovery action. Yeah, so it depends on the recovery action.
Okay,
So
so
you'll have something that's watching for new taints coming into PVs, and then looks at the PVCs to see if the PVC matches that PV taint, and so take action on it. Just like it's almost like provisioning, but I mean the design is similar to provisioning. Like you have to have.
so I think
external
that's where it actually differs from the way taints and tolerations work on nodes.
Because they're very specific, right? Like you can have a very.
So I think
Specific
for
list
taints
of-
and tolerations on nodes and pods, you have taints that are applied to the nodes and then tolerations applied to the pods. And then when scheduling happens, it takes the toleration of the pod and the taint on the node into account before it makes the scheduling decision. In this case, we're kind of flipping it. We're saying the scheduling has already happened. PV and PVC are bound. And now we want the toleration to be, the taint to be applied to the PV, and then action to be taken to undo the scheduling.
Right.
And that, I think, is where it gets a little funky for me.
In the node taints and tolerations, it also evicts running pods.
After the taint is applied.
Yeah.
And
Yeah.
is that a separate controller that monitors?
There is a node taints controller.
Okay, so then this would be like a PVC taints controller then.
Yeah, that's the thing. Like tolerations are exception processes, right? Like taint is like, hey, this bad thing has happened. And then toleration is like, well, in certain scenarios, I might tolerate that bad thing for something. Seems to me like we just need to apply a taint and then have a controller that does certain actions when that taint is there. But we don't need the toleration part.
What I think is more useful is to have tolerations in pods, not in PVCs. If a PV becomes tainted, then the pod should die if it can't tolerate the taint. Not the PVC should be unbound. Why this is useful? We should kill the pod.
So in the case of local storage, you can kill the pod, but because your PVC is still bound, your pod will get rescheduled to the bad node. So you need a way to lose the volume.
Well, the PVC is bound. That means there is data and we can't just delete the data.
Yeah, but that's why you only delete it if you tolerate it or if you can't tolerate it.
So I would say that sometimes you have PVCs that are in shared storage and some are read by only one pod. So we have to be careful that if we find a toleration that could affect many pods using this single PVC. So it would be better to put it in a pod because some pods could be able to handle it, some not, instead of having the PVC being able to affect many pods and not the none. Just my suggestion.
But if your action is to unbind the PVC, that's
Okay.
going to impact all your
So-
pods.
So that takes me to my second topic, which is I don't think we should take any action yet. I think we should first decide that we flag and we say this happened. We can even put the PVC in like a stop state or something, but we don't take any action as saying we're going to remove this PVC, we're going to unbind it and do something that it'll be very hard for us to go backwards, right? We just say we just stop, or we warn or something, or we send a signal somewhere. But I think that at first is a great first step. And I think once we gain the experience from doing that, then we can then decide what to do next after that, once customers provide feedback from that step. But I think the very first step is to say, look, we get this information, which is good. What do we do next from here? I think right now to plan the next step after that, it could be difficult.
+1.
Yeah, I agree too. Especially look at the case where, let's say you have a network storage system and the reason you cannot access your storage is because the top of the rack switch died. So none of the nodes in a given rack can access storage, but the nodes in the other racks can. And just because some nodes cannot access storage, you shouldn't decouple PVC from PV.
Okay, got it. I'm actually about to address that exact point, right? So this, I think the reason Michelle's going on about this is specifically for local storage. So it's back up on local storage, right? Remember, she said like this isn't for applications, or maybe if they want to use it for scratch space or something. But if you want like a redundant, like backed up, you use the network storage, not the local direct attached storage, right? So if you're using local direct attached storage, like why are we trying to bring that into the persistent volume framework? For scale out data management platforms like Mongo, HDFS, Gluster, Ceph, etc., right? And so we want to be able to deploy those with a stateful set, right? And so what happens is, say you have a 6-node stateful set and disk 1 goes bad, right? All of those can tolerate a loss of a node. And what we want to happen, the standard stateful set behavior, is mark node 1 offline so that a new replica gets scheduled on node 7 to recreate the 6-node quorum. But the way the scheduler is designed is to only always schedule that pod on what the claim that it's associated with, which is on node 1, which is offline. And so this is what we're going after here, just to clarify.
Yeah. So I mean, the problem with local storage is that once you're bound to local storage, you always have to be scheduled on that node, right? So if you want to maintain quorum by having a new instance on a new node, you need to give up your local disk.
I thought that we were talking about what's the generic case for this.
So I mean, there is in your toleration, you can specify effect, right? So for local disk use cases, your effect could be unbind. And for not other use cases, you could have, just like alert or, something else, right? It's not, I'm not saying that binding should happen for every single toleration.
I think when a node goes down, you should decommission everything that is dependent on that node. So whether it's the local volume on that node, the instance of an app running on that node, everything should get decommissioned. And
But it's not the node going down.
Not, yeah. It could be an individual disk that is being exposed as a local storage volume going down.
Yeah, maybe the cable just came to disconnected from one of the local disks, and the rest of the node's fine.
Yeah, but isn't the application going to complain then? Because it can't read from that disk
Well,
or write to
the
that disk?
application that's using the local storage, but maybe you have an application that doesn't care about local. Maybe you have another application waiting in the wings that wants to use NFS. It doesn't care about the local storage.
So the particular use cases for local storage is you are going to have data that's backed by the disk on one particular machine. If that particular disk goes bad and you have pods, your application may notice that this disk is corrupted, it's going to crash. Kubernetes is going to reschedule the pod on the same node because the disk exists on that node.
Right.
So if we have this taints and toleration mechanism, you could have a taint on that PV that indicates that it went unhealthy. And then some mechanism, some controller that sits there and watches it and says, okay, I noticed that this local disk has been unhealthy for 6 hours. Instead of waiting indefinitely and continuing to crash loop, I'm going to do something to rectify it. And the rectification is going to be, let me unbind this particular PVC PV so that it can actually be fulfilled from somewhere else. And it would be optional. It wouldn't be something that you would want to, it would be something that would be opt-in, but it would be a good way to be able to implement a recovery strategy for this case. And then you could expand it more generally beyond local storage by plugging in your own custom health probe that would monitor for things like network partition or whatever it needs to. I mean, it would be useful in the NFS case where your share is inaccessible or something like that.
Yeah, and I just wanted to add on the network thing that I forgot to bring that up, even though I started what I was going to say, saying I'm going to address that. So right, like this is the thing. Like when you deploy these scale-out data management platforms, right? They all hold a lot of data on their local disks, right? And so, like, if one appears to be offline to the scheduler, you don't want the scheduler just arbitrarily like marking it bad and creating a new one, because you'll create a network replication storm, right? Like a problem with the switch, maybe half the nodes go offline. So there's actually a toleration. You can taint, so the taint that gets put on the node is called no execute. Like scheduler can't reach it. And you can tolerate a no execute for there's this parameter called toleration seconds. And you can say, look, if you encounter this taint, Mr. Scheduler, don't do anything for this time limit. So you can actually create a time limit for whatever network partition or something to get resolved, so that it's not arbitrarily like creating new pods, marking others offline.
The way I view things is that if an application wants high availability, a disk failure shouldn't be any different than node failure. So I just have to, pardon me, no different than a node failure. So if my application, I have 10 running instances right now, one goes down, whether it's due to disk failure or node failure, what I'm going to do is I'm going to bring up a new instance somewhere else, right? And the application logic should take care of it, you know?
You just, well, it's not necessarily unhealthy. I mean, you're assuming there's one application running on the cluster. What happens if there's 25 or 50 different applications? Like the node's not trash.
If the node loses a disk, it's unhealthy.
Well, when we say loses a disk, maybe, yeah, maybe like there's bad sectors on it.
Right.
Degrading and
no, there's other applications running on the same node that are using different resources. It's just one resource that's gone bad
and that's
one
absolutely fine. But my point was just that continuing to schedule workloads on a node that you know is in a degraded state doesn't make sense. I mean, you can put in all the logic and everything else and figure out, okay, do I care?
Okay, let's go through a scenario. Right, Nginx.
Right, but do you want to?
Right, let's look at Nginx. So like I'm doing scale out web server, and then I'm also running Mongo, right? So I've got servers 1 through 6, and on each one of those servers, I'm running Nginx and Mongo containers or pods. And a disk goes bad. Mongo cares, Nginx doesn't care. So I shouldn't evict all the pods.
You know,
I
my
just
point is
don't
like,
want any more data disk stuff.
And to
on
be
that.
clear, I'm not necessarily saying you should evict the pods. What I'm saying though is you should not reschedule things to that node.
Well, it's like saying
that need disks.
It's like saying you're not going to drive your car because the radio doesn't work. Well, you know, like.
No, but I'm not going to try and turn on the radio when I know it doesn't work.
Right. You're not going to listen to music.
So we have we have a gradient here of node health. Everything is absolutely working fine, or certain components are not working. And it sounds like the part of the conversation that's interesting to me is that we have one opinion holder in the storage SIG, no surprise, one set of opinions, which is, well, if the disk ain't happy, the node should not be used, which, you know, makes sense from that perspective. And then there's, you know, another probably set of views, which is, well, if one disk is down, is the node degraded, or is the node unusable, or is the node, you know, get everyone out of the pool, or that we shouldn't let anyone else in the pool? There is the node problem detector, which is something else that's going on in the node SIG, which has a way of taking a look at the hardware and kernel system and gauging the health of that system, and then using that to feed into the scheduler and giving input in whether or not the node should be scheduling jobs or not. I don't know exactly what they've decided for disk health or not and how that fits into it. Whether, again, you've got a defect list that's longer than you think, or you know, you've got a whole drive that's gone and missing. I'm not really sure what the details are there, but we should figure that out and work with that group on that score, because, you know, it's easy to just sort of jump around in what we want in this room and not get a good decision out of it.
Yeah, my point is the same as John.
Okay.
You don't have to evict other nodes that are running fine. You just run the new instance of the application that just failed on a different node. That's
so
it.
my point is, I
And-
think there's a system in place already that's discussed a lot of these applications and ways to propagate these signals. And it's probably good to learn how that system's designed and if it takes these into account or not. It might already do so, as opposed to trying to recreate it here. So, Michelle, do you know anything about the node problem
Yeah,
detector?
so the node problem detector will taint the whole node, and then all pods will get evicted from the node. But in our case, it could just be there's this secondary disk on the node that only one pod uses, and the other 100 pods on the node do not use that disk. So all those other 100 pods, should not be impacted.
So, and I'll let this go if I'm just completely wrong, but so it sounds like maybe would it be worth looking into modifying that existing node behavior to not evict all the pods necessarily?
Well, so I mean, the main thing of the node problem detector is that it's trying to detect problems on the node that will impact the whole system. So maybe if there's a problem with the root disk, that could be worth a node taint.
Right.
But a problem with a secondary disk that only one application might use should not have a node taint. It should be a PV taint.
But I guess what I'm getting at is it seems to me that it might make more logical sense and more easier to manage is if you did have a mechanism in the node taint that said, hey, I've got a problem with a local disk. Do not schedule things that are requesting local disks on this node.
And the way we're exposing local disks is through persistent volumes.
Right. And my point is I think maybe that's backwards. I'm suggesting maybe it would be worth considering doing that at the node level instead and avoiding this problem of the evicting pods and everything else and stuff like that. And instead actually have specific requirements on the node taint that lets the node actually handle itself and manage its pods.
Wait, what?
I think this is going back to the have a special taint on the node for each volume, each local volume.
Yeah,
Yes.
I think, the whole design around the local persistent storage is that we use the persistent volume interface so that it maintains a consistent way to manage all the volumes that we support, so that you don't have to handle local storage in a special way compared to remote storage.
But local is a special case. It's a part of the node.
So here's my question.
Not necessarily. You could have external mounts where you have the network adapter that goes to the fiber channel or whatever go bad, but the root volume is.
So do we need to go, the question I've got, actually, I bring this to Brad, is having volume taints a finer granularity of the health of the node? Is it enough to say, are we just trying to, what problem are we really trying to solve? Are we trying to solve things that get stuck to a volume, or are we trying to solve to not use that volume again? Let's stick with remote volume for a second, or and forget about local storage for a second. Are we just trying to say we want to, optimize the node and still use the node even if just one of its volumes is down? Like, what is the high-level problem we're trying to solve?
The high-level problem is the local storage one. I see other applications to this, for more generically. Specifically, like if an attach fails for an EBS volume, it would be nice to have a recovery path, some kind of recovery path that goes and tries to, because if an attach fails for an EBS volume, it could fail because somebody manually attached it to another node. It could fail because the AWS API broke. It could fail because...
That's worth clarifying here is these are not in any of the, this is not a recovery for any of the attach, provision, or mount calls because we already have recovery mechanisms in place there.
These are
What's being discussed,
vendor-specific
well, no,
recovery
what's being discussed here is the health of the volume after it has become available to the workload.
Yeah.
Currently, once we make it available to a workload, to a pod, we're hands off. If something happens after that, good luck. If somebody pulls the plug, we don't know anything about that. And for general remote volumes, we haven't really had to worry about it because we assume that the underlying storage system cares about it. For local storage, it does matter because we're the ones that are exposing the local storage. And so what's being discussed here is if after the volume is made available to a workload, it's being used, and it suddenly becomes unhealthy for whatever reason, what happens? What is the recovery behavior? So,
or not recovery behavior, or are you trying to say the make sure we don't use it again behavior?
Or it's
both.
one
It's
is
recovery
discovery.
behavior and don't quit using it behavior.
Right. Discovery, like alert, figure, like let some other components know what happened, and two is allow those components to react to it. So what is the mechanism by which we should do this? On the one hand, what's being proposed is taints and tolerations on the PV granularity. On the other hand, it is something at the node granularity, and just to bring everyone up on the same page, I think.
So today, when you try to attach to a volume or mount a volume, in either case, and it fails, and there's a recovery mechanism, is this something that is, there's no state that's stored in etcd that says this did not work? Like, let's first say a volume as opposed to persistent volume. You have a pod, you have a volume associated with it, you try to get them to work, doesn't mount or doesn't attach, what happens?
The events are generated to indicate that this didn't work. The existing state of the system remains as is, and Kubernetes basically compares what the desired state is with what the actual state is, sees that there's a difference, and then continues to try to drive to that state with exponential back off on errors.
Yes, we have a generic recovery mechanism.
So all of that exists on attach, provision, mount, like up until the point of making the volume available, these mechanisms exist. But once the volume becomes available, there's nothing in Kubernetes that's sitting there and monitoring the health of what's going on afterwards. And if something becomes corrupted, it becomes unavailable, there's network partitioning, anything happens, we don't really know anything about it. We don't do anything about it. And for the most part, we haven't had to do it because these volume
So you say when an
storage systems are
application
remote.
is being used, so once the claim and the volume are
Are bound, and there is a pod using them,
Well,
and it's already mounted.
So this sounds really similar to like heartbeats or, like health checks that you want to have on a network service.
It is. These are kind of generic health checks. So in the AWS case, like we have like recovery and a retry that we go through to make sure we keep attempting to attach. But in maybe Azure, AWS, like there could be more cloud specific actions that we take to diagnose the problem, but there is no plugin mechanism to go in there and like try to figure it out. All we can do is retry until we fail, and then
Okay, so to jump up the stack frame then, it feels to me like there might be 3 problems that we're trying to solve. One of them is once you've successfully mounted, how do you make sure that you have a session-based health awareness of the system? Because we right now have no idea if after that initial mount point things go south. The other one is that if things do go south, what do we decide to do with the state of that node? And it sounds like the node team has already decided, according to what Michelle said, that if we have disk problems, we just get everyone out of the pool on that node. And then the last one is, how do we make sure that we sort of fence post or quarantine that volume if we think there's something wrong with it? Are those the 3 class of problems?
The second and third part is so the first part is absolutely true. We want to be able to know when things go wrong after the volume is available. The second is not necessarily what I believe Michelle is trying to argue is not necessarily the node's problem, because this is a volume which doesn't apply to all the workloads on the machine. It applies to a single pod. There's a volume being used by a single pod, and that particular volume has an issue.
That's semantic to me. I think it depends on where you sit. You can argue that if it's not remote, local storage is an aspect of the node's environment and a resource that's being offered to the storage system.
Yeah.
Or, you can argue if it's remote, then that's not the case.
Yeah.
So it sort of depends on either A, if you're hungry to solve this problem and what team you're in, or if you're hungry to throw it to someone else and what team you're in.
I think that's the debate right now.
So the ownership piece,
I
I would actually tend to believe that on the local side, this is something that would involve the node resource management, because there's so much infrastructure in place already for what's going on locally on that system, and they that's it. And so, and they have a lot of expertise and thought there already. I'm not saying we have to do it
I can
that way.
see it
So-
both ways right now. Go
So
ahead.
the node team manages the root disk on the node, but the node team does not manage the additional secondary disks.
So that's the other question. How often do we actually run without root disks in Kubernetes? I thought the prescribed recommended system was to have one big honking disk.
Yeah. But then you can add additional disks to it. So for the persistent storage case, we're talking about the additional disks.
I know you can. How often does that really happen? Do people do that? Does that solve their problem? Are we solving a problem that is not really that widespread?
Sorry, exactly which disk are you referring to?
I understand it's different on-prem, and I'm asking, as someone who's ignorant of on-prem, how often do people in this room on-prem do it that way?
We have customers that run big NVMe drives that want to use local disks.
Okay.
I work on a product
So I'm saying that the
I
comment
work on a
was
product
for-
that's doing this exact same thing,
Wait,
and
before you
we
get
have an
to
ever-growing
repeat
base
his
of customers.
Sure. So we have customers that want to run, normally it's like databases on like big old NVMe drives that get mounted onto nodes.
And we have customers that basically just want to abstract away local storage. So they just want to get whatever local storage is available and then abstract it over a software-defined layer.
I have a question. Let's just put Kubernetes aside for a second. You have a disk failure. What are some of the corrective set of actions you can take? One is like the RAID rebuild, which renders the node.
Let's discuss this in those three categories of problems that we're trying to solve. So we have a disk failure
On a node.
Okay.
Whether it's disk, NVMe, flash, whatever. It's local. It's a local component that just failed. The corrective set of actions is like, if you have a RAID setup, you have to do RAID rebuild, right? Which is a time-consuming process, can make the node useless for a considerable amount of time. So this goes again back to, you don't want to do that again of a disk, you want to do that again of a node.
If you have a RAID setup, though, you may have degraded performance, but doesn't the system still stay up and running?
Yeah, the system's
So it's
not
runs, but
worthless
it's
at that
degraded
point.
performance.
Yeah, but here's my point. That's a very opinionated answer for some customers, and other customers may not care. Like some of them may just be happy that it's up and running, be content to see the RAID scrub or the RAID deconstruct occur, and go on their merry way. While others are like, I've lost 1/3 of the performance.
Yeah, and wouldn't it also differ depending on the local storage solution? Like some of them could just be like, oh, this drive is bad. The rest of the system can keep running while I go over and pull out a drive and put a new one in.
Yeah.
With the same identity.
I would say, if we look at where Kubernetes is today on-prem, like it's less people, and in the cloud, like less people are interested in this exact feature. But if I look at, the use case that Steve was laying out, he was saying, hey, we want Kubernetes to do everything and be relevant to all apps. And so one of those new apps is like this distributed storage platform. And so if we connect that to the systems that NetApp builds, that Dell EMC builds, that storage companies actually build, what customers expect out of that is like a highly tuned and integrated operational aspect of it, like tying the hardware to the operations of the thing. Yeah, it's like
about for Kubernetes, because
yeah.
Kubernetes overall has, and this is exactly why. So yes, Kubernetes needs to be highly functional and on-prem, and I agree with that. That makes sense, and the NVMe stuff makes sense too, because I think it's a large trend that will continue. The point that he made about what to expect when you have a drive failure, which I feel is almost maybe possibly a more infrastructure layer than a Kubernetes administrator layer, and it could depend on how highly tuned things are. We are in other SIGs now, Kubernetes is hitting these questions of high performance computing. How much of a high performance computing machine should it be? How much complexity are we going to add to make sure that the telcos are happy or that certain workloads are working well? And because what we're describing here could easily turn into a whole lot of knobs. And this is why I was going back to, at least for me, trying to understand what are the 3 problems we're trying to solve, and then figuring out from those, what are the configurations that we want to solve for first as we make things increasingly more complicated. Because we could solve all of this stuff, and it would possibly be a more dizzying solution for, what makes Kubernetes, I think, successful is that it's fairly straightforward to grok. And understanding if, the right answer might be, I'm not saying that it is, but on one gradient, something's wrong with the drive, everyone gets off that node and moves on. It's a very simple, easy to understand answer. It may not be the right answer based on resource consumption, which is why I was curious what people were seeing in the enterprise or on the on-prem solution. And I don't know what the right answer is, but it feels very faceted, and that's all I'm trying to say.
Right, and I share the same view. I think these are complicated problems, and it doesn't make sense for the Kubernetes local volume plugin to replicate what a NetApp system or EMC system does behind the scene whenever this goes down.
So that's what I'm saying. So this is why it's pluggable, right? This is why I propose this is a pluggable solution. So we don't dictate what the taints are. We don't dictate what the recovery action is. It depends on what the vendor wants to do, how they want to taint their device, and how they want to recover from it.
And don't confuse what I was saying, right? What we're doing in terms of NetApp and EMC, et cetera, what we've done for the last 20 years, we're trying to transfer that to the software world. And Kubernetes is a platform that could actually be that complete control plane for data center resources. And so we're trying to get that same level of functionality where we can take what they expected out of proprietary hardware, run it on top of Kubernetes, and that's essentially this cloud data storage platform, orchestrated storage platform, whatever the term is. It's an interesting area.
Yeah, I mean,
so
I think
shared this. You said you were moving to software. Yeah, the software storage system should take care of these complexities, not Kubernetes volume plugins.
Can you define complexities though?
When this goes down, how you can recover from the failure. Whenever there's some.
That's an infrastructure thing in general.
Right.
Usually, it depends, right? For if you're running on a big piece of iron, a disk goes down and you're something Kubernetes.
Yeah, but how that's handled and where we place the workloads, right? We can be smarter with more information, all the telemetry information, we bring it in, and we can make better choices about where to place it, right?
I think that's a question that we as a SIG need to figure out, which is how much visibility into the infrastructure do we want the cluster administrator to have?
Yeah.
And we can easily make them dizzy with that information.
Right.
And so do they look at a big file controller or a big filer that has 20 drives inside and one drive goes down, but the system's still up and running? Is that something that the cluster administrator needs to know?
Yeah.
Because often they'll have a hot spare going and then you wait a day and everything's fine. Or is it something that they need to know about the status of every one of those drives? I think one of the advantages and all the reason for dynamic provisioning is that we've abstracted out a whole bunch of the infrastructure complexity to the cluster administrator user and definitely the app users. And so exposing that, seems for me really natural and fun, because I think everyone here knows my hobbies and what I have in my garage. I'm not sure how many of the cluster administrators are going to want to have that knowledge or not. And I think that's what we need to be aware of. And to fall back again on the point I was trying to make at the beginning, a disk health check is to me something that's very different than a disk quarantine. And so, maybe you want to have something that says make it a plugin or a policy that you can set up that says if one drive, if this storage system is degraded in any way, shape, or form, quarantine it. And then get everyone out of the pool because we care about performance versus, you're more tolerant of those sorts of failures. And there's some way of having that information be abstracted out. I don't know. But I think the health check versus quarantine ideas are a nicer Kubernetes way to think about these things. And maybe quarantine isn't the right one.
And so you asked for the steps, and would the first step be to just gather more information, bring in as part of the volumes status indicator so that you can build custom controllers to do stuff?
Yeah, I think it would be. I mean, whether you choose to quarantine the whole node or not, you need to know it happened. And to even be able to make the choice, something has to be monitoring it and reporting it on some level.
Well, okay. So the problem with that is if you buy a Western Digital hard drive or a Seagate hard drive, they both come with different monitoring softwares, right? The monitoring for the local storage or the remote storage, it's going to be different no matter what kind of storage you're talking about. So there's no way for us to generically design that. We have to have a framework where they can go put the monitoring stuff in and then do something once the problem is detected, right? And then some kind of recovery thing that's going to be dependent on the vendor as well.
Many types of volumes to deal with, but if you just take the volume plugins as an example, like what can be done there? That you could add a status tag, and then the volume plugins could have a list call that actually brings back the status to run it to update the PVs.
Well, how's that different than tainting? I mean, you're putting a status on the PV with a taint, right?
We're losing track of the app over here. So what Michelle was talking about is these distributed data stores. The problem you're actually describing, the local storage one, is that there's a stickiness to the PVC. So most likely you're going to be using a stateful set here. Stateful set, once you bring up a node, it is sticky to that PVC. So even if we figure out that we're not going to schedule the same pod on this node, it's still not going to come up because the PVC is sticky to this node and will never move. That's why you need to break that binding, right? So, and the other aspect here is that we can't solve this in storage because the app developer, the person who is writing the stateful set, will need to be saying that I can tolerate this, I'm okay getting rid of the data, I can move over. So even though we need to break that stickiness, this does not live here. This
determine the policy.
Exactly.
Yeah, but you can't report.
I'm not sure.
I think these perspectives here, we're seeing a differentiation between appliance perspective and software-defined storage. I can speak for Gluster and Ceph, where all we want is just to be able to mark a disk offline and be able to respond in a stateful set. Like Gluster and Ceph both want to use this feature. So if you want well, maybe I'm just being overly generalistic, but I'm just saying, like, if you want like anything more than that, more power to you. But I can tell you for Gluster and Ceph, we want this feature. And that's all we need. We just want to move to a stateful set.
So I wonder if
we want to be able to deploy on local disk with a stateful set.
Sure, but what about the Taints
and it will, and obviously that comes with it. Like we can't use it unless we can't do failover unless Michelle's features in there. Correct. Yeah, you're right. We can use block, right?
In cloud, you can have.
Yeah, that's right. But in the cloud, you just benefit more.
This exists in the cloud as well.
Yeah, so in the cloud, you have local disks too that are like an order of magnitude faster performance than the remote block storage. So if you want.
No, I agree. What I'm saying is that instead of using the technology of local storage, you will use the technology discussed yesterday by Aaron, using block storage. You would ask for block storage, and the CVS block would attach, and they will go.
Yeah, but the remote block storage is still going to be slower than a local block storage.
So you're saying cloud vendors will supply local storage?
Yes.
Amazon does it.
Google does it. Right. And the local SSDs are an order of magnitude faster.
So back to your design real quick, Brett. So I was mentioning the information and gathering. How is that done for the proposal? How are you getting the information about why it needs to taint?
So how do you get information about?
Yeah, like
how does something become tainted?
Yeah. It sounds like it would be an external component, right?
Yeah, you'd have, well, so you probably have a daemon set deployed to your entire cluster that would sit there and look at the
monitor
PVs,
the health.
Look at each specific PV that it knows about. And then once the volume becomes unhealthy for whatever reason,
but how does
taint the PV.
How does a PV become unhealthy?
Depends on what kind of storage you have.
But how does that information come back to the
well, let's
PV?
say it's local storage. So if your local storage health monitoring service may be looking through your system logs for, read failures, block errors.
But how does that come back to the PV though? Like, is that in the plugin or?
You'd
have to taint the PV.
You modify the PV object with a taint.
Yeah.
So someone manually does that.
Your health monitoring.
The health monitoring.
Health monitoring would add
two questions. One, a taint, is it a label or is it something more sticky than a label?
It's actually a specific field called a taint. it's not a label.
So it's very close to a label, though, right? I mean, it's,
Yeah, but it's like a whole separate field that is treated very specially.
So we should talk to Eric Toon, who's got a bunch of experiences, I think both good and bad, with taints. And so I think that, Brad, if you do want to pursue this, I think you definitely want to get his ear, because that's all. He has a lot of experience about what he would have done differently.
so he's tainted about taints.
So the information gathering part, like we have volume plugins, and AWS has a status in that volume plugin, or it could, like, wouldn't that be what we'd be looking to
Yes,
actually
right.
do
For
the update
AWS,
to the
you'd be
volume?
looking at a status object or something else.
Okay.
And for PDIS, could probably be
Like,
like
it wouldn't be
similar.
a separate controller running that's responsible for talking to
Yeah,
AWS.
not necessarily.
and
You
then-
might not have to deploy a daemon set in a cloud provider. You
Right.
may just be
That's
able
what I
to
was
use the
getting at,
cloud
is like,
provider API in a
it might
single
be an
controller.
interesting addition to CSI, added to the scope of that at some point in the future. But
Yeah, depending on where the rest of this lands. but-
Health checks are complicated.
Yeah, but first, I think assuming we have some mechanism to do a health check and figure out that a volume is unhealthy, I think that part, it sounds like it's a good thing to have, at least just to be able to inform end users. The more interesting aspect here is, what do you do after a volume is marked unhealthy? It sounds like the debate has forked in two directions. One is for local storage, if a volume is unhealthy, don't worry about it at the PVC level, mark the node that it belongs on unhealthy and let the scheduler take care of it. The other camp is arguing that that's too heavy a recovery mechanism, because it's going to affect other workloads that are not necessarily that shouldn't necessarily be affected. And is there a mechanism by which we could do this at a finer grain, basically at the volume scheduling layer? And I don't know what the clear answer here is.
So he left. To make sure I'm clear from Red Hat's perspective, I think I see the problem that you're trying to solve is you want things like Ceph and Gluster that are deployed in pods to be able to be self-healing and move over to another node. That's the bottom line,
Yes.
right? Okay.
Yeah, we don't want one failure to be catastrophic.
And my point about, just to be clear, my point is not to treat a disk my point is to treat a disk failure like a node failure, but I'm not saying we should use node taints to make that happen. We're not going to evict any pods that are working fine on that node. What we're doing is that we're just treating, let's say if we have a Ceph instance or Gluster FS instance that have 10 replicas. If one of them goes down, we think it as is the whole node went down. And now you bring up a new instance. This new instance can go back to the same node that had the disk failure, or can go to a new node. If it goes to the same node that had this failure, it may get scheduled on a working disk, or it may get scheduled on the same faulty disk. If it gets scheduled on if the local PV is provisioned on a good disk, we're fine, no problem. We proceed. Ceph Gluster takes care of replication. We have now 10 instances. We're back to a desired state.
So the health check could do both, right? And I see instances where you may want both, because you don't, if your local storage is compromised in some way, you don't want to keep scheduling stuff there and have it tainted and unscheduled and brought back someplace else.
And
I really wish that we could almost stop thinking about storage and instead think about failure domains instead. Because I think when we start thinking about storage, there's the first question that comes to my mind is, what is unhealthy? And that, with all of us in the room who know way too much about storage, that gets really detailed really fast. It sounds like, and also there's the node as a failure domain and the storage that's also associated with it as a failure domain. And if we look at it on a high level like that, it's really about what does it take to keep that pod running? And when do we know when the failure domain has failed? Like, are those, if we could satisfy those two?
Looking at it from the pod point of view actually might be a good lens to look at it. So in the end, it's not necessarily about the PV or PVC, it's the pod that's consuming it.
Right.
So if a particular volume becomes unavailable, and
wait, don't even think of it that way. Think about if the requirements for that pod to run are not met, which
That's a
could
boot.
be node, pod,
Right.
networking, any of the above.
Right.
How do we make sure that it's aware of these situation
Yeah.
and then gets scheduled into a place where it can continue running?
And there must be, so in the existing non-volume world, there are cases in which this can happen. The application itself can get into a error state and crash. It can run out of memory. All sorts of things can happen. And the way that Kubernetes handles it today is that the pod is terminated, and then the scheduler, if the pod is the only instance of the pod running, nothing happens. If you're running it through something like a replica set, a new pod is created somewhere else, and the scheduler figures out where to schedule that. I wonder if we could reuse that sort of recovery mechanism here. So if the resources required for this pod, which include the local volume, become unavailable, we'll have some mechanism to be able to say that happened. Then the pod gets terminated. But I guess the reason this was brought up is because the fact that stateful sets are sticky to a particular volume, which goes back to your point.
But how do stateful sets work today? And I think this again brings us back to taints. How do stateful sets work today when the node is tainted in some way?
It works fine without local storage.
But
because if the node's tainted, the pod will move over. It'll always use the same PVC.
Mhm.
But PVCs today with dynamic storage or that are not local storage can move over. It'll go to wherever the pod is. The problem is that the local storage PVC is always bound to that node. It doesn't move.
so there's a situation then when the volume is truly unusable by the stateful set, that then the stateful set pod will become pending forever. Is that correct?
Yeah.
So I really think that's the way to focus on this, is to look at it as like, these are the requirements of what it takes to keep the pod running, and think of them as all of the pieces of the failure domains, and to realize that what makes the volume interesting is that you might not be able to recreate that volume again, and then it just goes pending.
So somebody here mentioned earlier about the tolerations should be on the pods. And I think that might be an interesting idea. So if a volume becomes bad, the way that we surface it is a taint on the PV. But the toleration is not necessarily on the PVC, but it's on the pod itself. So,
but the challenge we have is that multiple pods can share one PVC.
And that's okay. Each one, so once a PV is marked, then all the pods that are referencing that PV, unless they have that toleration, should be terminated. And when a new pod comes up, if they don't have a toleration for that volume, they'll get pushed somewhere else.
What if one pod tolerates it and one pod doesn't?
But that might be all right, because here's how we're encoding policy in a system that the users already understand that's consistent, without making it overly complicated.
One doesn't. It's the recovery action to like break the binding and rebind it is going to be really confusing to one pod.
But you don't need to break the binding. I think what I'm getting at is you leave the existing pod and bound volume alone. You terminate the pod that's referencing a bad volume, and you create a new volume will be created to reference it. The problem right now is when the new volume is created, it's going to be sticky to the existing PVC. But if we build in a PVC toleration mechanism into the pod, then it's not necessarily going to reuse the original PVC, actually.
So for stateful sets, the PVC name is always the same.
No, and the thing that also breaks down here too is that sometimes, let's say the pod starts pending because its volume is really, really gone, then we don't have a system in place to do what Brad wants, which is to say, great, provision a new volume and then move to that volume instead. That's the mechanism piece that's kind of missing.
Yeah, and that's the stickiness of this.
It's not sticky. It's kind of weird. It's like the CPU instruction that says, do what I tell you to, except when I don't, do what I say, except when I don't want you to. It's
cloud.
Right.
Using local disk in cloud.
Well, but this is like, use that storage unless you can't use it, and then copy a new one instead.
So
Just to add, the policy that we're talking about here is actually encoded in the stateful set. So it's just that stateful sets today only have one policy. Always create a PVC when it doesn't exist, and then never never do anything. Always might be that. So I think stateful sets are where we've been talking about policy. This is where the policy belongs about what to do in case that PVC is no longer usable. Yeah, what is the stateful set?
That's a good point.
Because the stateful set is backed by something like cluster that has its own reputation, that it can't be, forget about it, just leave that disk alone. I don't need it. I'm going to create a new one. I'm going to re-replicate it. The problem is when you don't have replication in the local storage, but the stateful set would indicate how many replicas actually exist. Therefore, you can create the policy around, okay, there's only one replication of this, and maybe I want that pod to stay in pending until I can try and fix my disk and get it going again for this critical application.
Yeah. And this will work today if you scale it. When you have 6 replicas, one goes down, you scale up the stateful set to 7, you only have 6 working. One will not keep working. But the idea is that's not what scaling up a stateful set is not meant.
Yeah, it's almost like it's a new API. You won't get that new one until the old ones are all back up and running. Right? Stateful set has an ordering associated. So if you increase the replicas, it's got to restart the lower numbered ones. The lower numbered ones have to be running before the next one will start.
Yeah. Are we talking about a new API object?
So I'm not sure that I followed the modifying the stateful set definition, but what I was sort of thinking of along these lines is whether we're talking about a new type of PVC actually that is, I'll call it a rebindable PVC. Right? So you could instead of having this
like that's exactly the problem we have with the log devices. I mean, that's the whole thing. And then we suddenly see, rebind it with something else underneath it. Wasn't appropriate. I'm sorry. I had actually thought about that. So, I mean, mentally, something that's rebindable, but I think the risk in rebinding outweighs the benefits of doing that because it opens the possibility to binding to something that we shouldn't have access to or don't want to bind to. And then there's a lot of sorting out of how we should do that.
Yeah, I agree. I think the idea of having a PVC be unbound and then rebound to something else and changing the meaning of it is a bad idea. What I would like to see happen is the changes made at the pod or stateful set level. And it sounds like that's where the problem is. The problem is that stateful sets today, each replica has an identity. And the problem is that one of the pods that is serving one of the identities, no matter how many times you restart it, isn't going to be able to start. So this stateful set controller, I think, should be modified to be able to have the recovery behavior for that case encoded into it, meaning it will necessarily have to basically the PV-PVC pair that went bad, set it aside, create a new PV-PVC pair to back that, and use that to bring that bad pod up.
If you added a definition for like secondary and tertiary PVCs in a stateful set, and then it could know. Okay,
fall back to this.
Something want to now go to this one. Oh, that go to this one. And that would solve the problem.
It sounds like to me that we should be solving this problem at the stateful set level and not. I agree with Aaron. Breaking that PV-PVC binding and then using it somewhere else is going to result in bad things happening. We should be handling it at the workload layer rather than trying to implicitly do things under the cover and hope that the application knows what happened. Yeah, that's a good question. I think that would be the same mechanism. This like, it feels like
solve her problem though, right? With local storage at all.
It would.
It's not a stateful set problem.
It is a stateful set problem, right?
Well, if the health monitor deletes the pod, the PVC, and the PV, then stateful mechanism would bring up a.
And you don't even have to delete the PV PVC. You leave the PV PVC intact as this is dirty, it's bad, it's pointing to a volume that is no longer available. You kill the pod, and then you create a new pod that doesn't have an affinity to that existing PVC. And you need something to be able to tell it, hey, new pod, don't go back to this existing PVC, create a new PVC. And the mechanism that we have to control that today is the stateful set controller.
But in the case of stateful sets, the PVC names are deterministic, right?
Yeah. So
but if you delete, you don't have to worry about it. You just delete it and have a new one created.
Find it.
Right.
The PVC is a claim.
Right.
PV is the one with the problem.
Yes, but the assumption that's been made so far in the system is that once a PV PVC is bound, it is one and the same thing. Like this is the way you refer to this PV until it has gone through the reclamation process. And now what we're saying is that actually it hasn't gone through the reclamation process, but we want to break this link and have it reference a different volume, and that doesn't sound like it's a good idea.
Well, just from a user point of view, when the stateful set is deleted, PVs are maintained. So in that same form, when a PV goes bad, PV should not be deleted.
Right. I agree.
That's all I'm saying.
Yeah, I think we agree with that. But then the question is about the binding between the PV and the PVC. Should that be broken, or should that be maintained and set aside as this is dirty and let's create a new PV PVC binding? That seems like a cleaner.
Can you scale up one?
Well, you can't create a new one with the same name.
Yeah, that I don't know what we could do to get around that.
Can you scale up one?
Oh, scale up one. I think somebody here mentioned that if there's one, I think you were mentioning if one ID is unavailable, then you can't scale up.
So I think it's possible, like change the controller, stateful set controller, when the pod is killed and restart, right? Because of this local storage volume problem, and use a different name for the PVC. It's not like very difficult to do. So each time the pod
I think so. So the way the stateful set PVC names are generated, it's just a prefix dash number.
Yes, it's based on.
But I guess what you're saying is maybe we can modify that so that when we create a replacement for prefix dash one, you have prefix dash one dash backup one. And if that exists, then you fall back. I guess it's possible. I would prefer that. I'd much rather prefer that solution
that's true,
than breaking PV PVC binding.
So taints and tolerations are dead?
So I think we could still use, so the other part of the question is how does the health information get surfaced? And in order for this to work, the stateful set controller still needs to be able to respond to something. The thing that the stateful set controller knows how to respond to is the disappearance of a pod. What that necessarily means is you need something else in the Kubernetes ecosystem that will terminate the pod if the volume becomes unhealthy.
So I think even if we process this at the stateful set controller level, you still need some way for the controller to know that a volume has gone bad. And you need a way in the stateful set to specify what your user's policy is.
So, and we're focusing mainly on the stateful set here, as that seems to be our main use case for this. But I could also be using a local volume in any other sort of construct.
Yeah, but the other constructs are much easier. So, for example, if I was using just a pod directly, and the volume that the pod is using, this was to Michael's point, if the volume becomes unhealthy, that means the resources that are required for the pod are unavailable. And the recovery mechanism in Kubernetes is simply terminate that pod, and then some other controller will bring that pod up again, and it should get rescheduled somewhere else. But actually, no, you're right.
Let's say I have a replica set
Yeah,
that
and
has
it's
that
referencing a
references a
PVC.
PVC.
Yeah. Yeah. You're right. It's more general.
But just to add, stateful set is being proposed as a mechanism where you encode policy for stateful applications. So if you're using a deployment, for example, it's really not meant for, and you have a stateful application that'll work, but if you have additional policy, where this is being thought of is stateful set.
Yeah, actually, there are a lot of issues with deployment using volumes.
That's a good point. I think that's something we should start reinforcing in our community too, is if you want to be able to scale out stateful workloads, you should be using a stateful set and not deployments or replica sets or anything else.
And also, I think the node taint actually probably can be used here because it's not just one value, it's a key operator and a value. So you can have different taint saying like prefer not to schedule or no execute. That means pod should not be executed or no schedule. So it's kind of a very rich syntax. So I think it's possibly use just node taint to present this disk has issue, and for those pods that cannot tolerate this disk failure and be evicted, all the other pods will not be like affected.
So, but then you have to encode the disk name or something into the taint. And then that means your pod has to, when you create your pod spec, you have to already know the PV name that your PVC is going to bind to.
Not the name, maybe just indicate that it used disk, local disk. And so if local disk fail, then it should be evicted.
But you could have two different stateful sets with two different types of local disks, and maybe only one of them fails.
So you mean those two set of stateful sets react differently for local?
Yeah, so you could have like two different stateful sets, and they both happen to use two different disks on the same node, and then one of the disks on the node fails. So you don't want to kill the other stateful set that was also using a different disk on that node.
But this is really just a debate of what sort of granularity we want to take it down to, right? The coarse thing is to say, well, I'm just going to say the whole node is bad because I've got a bad disk, right? My radio doesn't work, so I'm not going to drive my car, which, you could do that. Or we could go and take it all the way down to the level of the disk, or hell, even a partition on the disk if we really wanted to go that far, because, that's where my bad sectors are. And so, I think that's just a sort of arbitrary decision that we as a group are going to have to figure out as to what sort of, detail we want to go and implement.
The that makes the most sense is the pod. Whether the pod has sufficient resources or not, I think that's where we should be. Marking a whole node is too big. Marking a individual partition is too small. Pod is where what I think.
Yeah, I think we need to stay there, because from disk to partition to cylinder to blocks, I mean, it can get pretty fine grained. So I think focusing on the pods requirements is really instrumental. And I think that's also something that the infrastructure should be in charge of. So when you're an infrastructure and you're offering resources with your provisioners or to Kubernetes, you can say slice this up in partitions, or slice this up by drives, or whatever you want, whatever the mountable or the raw blocks could be. But that granularity to me feels like it's an infrastructure decision, and that's something offered to the cluster administrator, who then manages this by volumes. Does that make sense?
Sure.
Okay.
I mean, it's still kind of an arbitrary decision, but I think it's reasonable because it's consistent with how we work with resources.
Absolutely, and it's not arbitrary. It's specific to the infrastructure administration and whatever they've got. which I think is the freedom that we want to make sure that we preserve, and that we don't want to be opinionated from there. That because I worry about the slippery slope.
I will say if my brakes don't work.
Okay.
Sure, but you know what? When I was younger, I didn't really care if the brakes didn't work. it depends.
Yeah, I still don't know if my parking brake works.
So the other thing I wanted to potentially bring up is if we want to go for a stateful set only solution, if in the future, say, daemon sets also supports a volume template kind of thing, then this same issue might come up for daemon sets.
If that's the case, then we can modify it similar to stateful sets. The problem with daemon sets today is the exact same problem that exists with replica sets and deployments, which is they don't work well with stateful applications. They let you reference one PVC, which makes no sense in a daemon set. If you have a new API that's introduced, the equivalent of a stateful daemon set, then this logic would have to be encoded there as well. I think the question still remains about exactly how to surface this, whether it would be a taint on the node level or it would be a taint on the PV level. But I think we're starting to, or I'd like not to have the PV PVC break. I think that's the one thing that just sounds like a really bad idea.
So do we have someone taking notes? Because it's so what are the givens that we all agree upon? It sounds like we've come to.
So does everybody agree that breaking PV PVC binding as a recovery mechanism for a bad disk is a no-go? Does anybody disagree with that? Raise your hand.
I don't think it's horrible, right?
Actually, I don't quite understand the pushback against that. I mean, I know I mentioned.
Do you want to explain, Jan?
Sorry.
The pushback against breaking PV PVC.
The pushback was we spent
binding.
4 days in a room trying to get the binding controller to work.
No, so actually, not breaking binding, but deleting the PVC, getting rid of the PVC. Is that the same as breaking the binding, or those are two different?
Deleting PVC is dangerous because it's user object. That's the only thing that the user sees. So if there is some error, then
I think he meant delete PV.
No, so going back to again stateful sets, because
So my problem with deleting PV PVC is the PVC is the mechanism by which a user references a volume. PV is the cluster representation for a volume. Just because a volume became unhealthy is not sufficient reason for us to eliminate all traces, all handles to that volume. Those should be user-initiated actions, right? So if a volume is marked unhealthy, leave the PV PVC intact, give some mechanism, we can determine what that is to say that it's unhealthy, and have the stateful set no longer use that PVC. And then create a new PVC PV to
Right.
fulfill that.
But see, the problem is then we have to start designing schemes in stateful sets to handle the naming and what's going to happen there.
And it already does, right?
But what I'm saying is there's already, stateful sets already have a scheme to create PVs and PVCs, rather PVCs.
PVCs, correct.
And so as long as we have a mechanism to surface that there's an issue here, the recovery mechanism from this can still be delete the PVC via the stateful set controller that created them to start off with, and then just recreate and then start from scratch again.
So the argument here is that the PVC in this case was not created by the cluster administrator, it was created by the stateful set controller, and therefore a valid recovery mechanism is for the stateful set controller to delete that PVC and create a new one.
Right, and then this policy should be encoded in the stateful set.
yeah, this is very unexpected by the user, and you delete all the traces, but the data is.
No, so what I'm saying is this should be encoded in the stateful set when you, as this is a mechanism that we would provide with stateful sets. It is under the control of whoever is writing the stateful set. At the end of the day, if I am a Gluster developer or I'm setting up Gluster and I'm creating a stateful set for Gluster, and I want this recovery mechanism, I'm going to have to encode it somewhere. We can't as policy. So
I think
I'm not saying doing anything under the covers. Yeah.
And I don't know if I agree with it or not, but the counter argument is that just because a volume went bad, if we delete all traces of it, that sounds like a bad idea. What might be a better recovery mechanism is set it aside and create a new replacement to use the replacement instead, so that a cluster administrator that comes along and says, what went wrong? I mean, everything is working right now, but I see there's a warning that said that this disk is bad and that it's accessible through this PVC and PV, instead of deleting all traces to it and saying, good luck, buddy, you figure it out on your own.
Right, right. And
the other nice thing about not deleting the PVC is that it doesn't get made available anywhere else theoretically.
And also for forensics,
yeah,
like one of the things that
debugging.
So when we write this up, I think we also need to write up the requirements, including like debuggability of this. Often when these failures occur, let's assume that magically the system has fixed up our application. You're going to want to know what happened to the infrastructure and what the reference was and when it happened, and be able to track that easily. And so they need to be lying around, and they need to be easily discoverable from both cluster administrator and the infrastructure side.
Right.
Yeah. And I will add to that that's really important, but there should be, if this is the correct direction, they're just saying if, there should be a maximum number of times that you do that. Because if not, you're going to start creating.
Right. Anytime you have an error recovery strategy that is encoded somewhere in the API, there should be a.
Just like.
Yeah.
I think that makes sense. I was just treating PVC as the current reference and PV as the one I had referenced. So deleting the PVC and then having the reclaim policy take care of whether we actually want to get rid of the PV or not is an option. But trying to now have, mess with the naming scheme of stateful sets to try and have,
potentially that could be, this could be encoded as a recovery option in the in the stateful set controller, meaning if a particular disk goes back bad, what do you want me to do? We already have retain policy on PVCs, right? It says retain this disk or delete this disk. And when we create this new policy, we could either reuse that or create a new field to say, as part of the policy, you define what happens when a disk goes bad. If you are a cluster administrator who doesn't care and just wants it automatically replaced, then we'll kick it off and replace, delete that PVPVC and create a new PVPVC for it. And if you want to retain it, which should be the default, then we set that PVPVC pair aside and create a new one. So that way you let the cluster administrator decide.
And we can do the renaming on the faulty PVC PV, and for the new ones that get created, we retain the same naming scheme that
it would. We'll have to look at the naming scheme. It would have to be like a prefix of a or something like weird,
faulty or something,
like dash backup. I don't know.
You can't rename API objects.
You'll have to rename the new one to something like a backup or something.
Name star stable.
Yeah.
This makes my head hurt. I think it needs to be written down.
Yeah, Brad.
Wait, I was supposed to do that?
Wait, what?
I just had my proposal rejected. I'm too distraught. So you have notes on this? Yeah. So the plan
Michelle,
is
do you think this would work for what you had in mind for the local storage? Yeah. Okay.
Okay, so the plan is to modify stateful sets to add policy to have a recovery.
To have policy to be able to recover from unhealthy volumes. But now the question that remains open and unsolved is, how do you surface that a volume is unhealthy? Taints and tolerations made sense when they go together. I'm not sure the tolerations part is strictly necessary in this case.
I think it's useful because the PV can be offline just for a few minutes, and that's okay for the application, but few hours is too much and we should rebind or delete it and create again.
Yeah, I agree. There has to be a limit because you don't want it to have a fluctuation.
Also, this toleration could limit the number of time, or not number, the frequency recreate new PVs and PVCs.
So would the toleration be applied to stateful sets?
Probably to stateful sets.
So we're gonna have to coordinate with the SIG apps also, because they are the folks who are on state. And they actually, stateful sets, did it just go GA?
I'm not sure.
Yeah, it's still beta? Okay.
Yeah, absolutely. We'd have to run this by them. But it sounds like if we have the taints at the PV level, that would be the mechanism by which you mark a node unhealthy. And then the tolerations could be the mechanism by which you encode the policy of the recovery behavior.
Wait, taints at the PV level mark the PV is unhealthy.
Mark
correct?
a PV is unhealthy, and then tolerations on the stateful set as the policy handling the recovery mechanism.
And on the pod view.
On the pod. Sorry.
The PV is automatically generated.
Yes. An external component that is interacting or that's monitoring the disk would monitor the disk and then update the PV that's representing that disk.
So something needs to be done so that can map the PV to the disk. That's it. That's okay.
Yes.
Because this is again one of those issues that we may have in CSI when we talk about how is that map.
Yeah, so I don't know if the health probe itself needs to necessarily be exposed through CSI. I imagine it could just be another controller that is running an external controller, which is monitoring the disk independent of everything else. And
how is the controller going to know that this disk has the issue? What I'm trying to say is like maybe what you were talking about before,
So I'm
the
thinking
CSI has an API to be able to say this list of health of IDs, and then the callers take that ID and maps it to a PV to be able to taint it. There needs to be something in between. How do we map PVs to actual?
Like that,
yeah.
The controller who has the list volume functionality.
Yeah.
Yeah. Cloud provider just to say at a cloud level, what's the status of this remote volume? And it wouldn't have to do with any like status symbols that Linux is reporting at this level. It's the cloud provider reporting back the status for that volume to apply taints to remote volumes.
But I'm just thinking that okay, that's for local storage, right? Because it's CSI would be a driver providing that. I guess what we need to think about is what's the end-to-end view?
Yeah. I think we need to sit
Yeah.
down and figure out what the intent will look like for
So
this.
this is a lot of pieces, right? There's the health check design now
Yep.
for storage, which also has to go into CSI. Does CNI even have health
It
checks?
may or may not need to go into CSI. I think we may be able to get away with this being a component that is independent, but we'll have to flesh the
I
details
think
out.
if we want to have some sort of health check mechanism, and I
Yeah.
still say that's if, we should figure that out.
Yeah.
It might be, do we want something interrupt based? I have no freaking clue. Basically, it sounds like the real requirement is after you've started a session with storage or with the volume, how do you know when the manager of that storage feels that it's unhealthy?
Yep.
And I think that's the way I'm being careful with the wording is that the cluster administrator doesn't have to think about sectors or network load or anything. It's completely abstracted out. And
Right.
I would love it if it's just a Boolean that says unhealthy as opposed to, any more detail.
That's
than
what
that.
like having an unhealthy on the PV would be a really dumb, simple way of going about it. But Jan and Aaron have a good point where you probably want more policy around this. Like if it's unhealthy for a certain amount of time, then do something about it rather than as soon as it happens.
Maybe
I don't
not.
know.
Maybe the
Yeah.
controller should say how long until it's really unhealthy, right?
That's also a good point. So I think we agree on that the recovery mechanism should be at the stateful set level. The mechanism by which the health is exposed, we're not certain of yet. It could be taints or tolerations. It could be something else.
I just want to say that it's kind of like John said, that this could get really, really, really complicated.
Wait, when this is an hour ago,
Yeah, I know.
like, why?
Yep.
When I'm writing a distributed data application, I actually know the health, and typically I'm seeing what's coming back in my application from storage. I actually know as cluster things are going wrong. I just want to move off this.
So you're saying that the pod itself could identify that the volume is
Actually, I do that today. So
okay.
what I do this is I fail the health check on the pod.
That's a valid.
I am going to get rescheduled. Just let me do something with this PVC.
That's a good point.
Yeah, there's no. I don't think we need health checks for this feature, for this requirement. We don't need to add any.
Yeah. So then I think what it's coming down to is perhaps we could decouple these two feature requests. One is health probing and surfacing that. And the second is recovering when a volume marks a pod as unavailable.
It's not even probing. We haven't even yet decided if it's a push or pull.
Right.
So just, awareness.
Awareness that a volume is unhealthy.
What's the signal for when the storage is unhealthy?
Yeah. So I think what he's proposing is if the application itself running inside the pod recognizes that the volume is unhealthy,
Node Problem Detector today just greps dmessage a lot.
Yeah.
And then that's how it knows a lot of the local storage when it's
only
bad.
Funky thing about that, though, is that now we require the application to be aware of Kubernetes primitives. It will need to necessarily talk to Kubernetes to say that, hey, this is what's going on, right?
So this is already the case because you containerize my application.
Yep.
And you have, when you containerize and you create a pod spec, you've got a health check in there. And you're supposed to do something with that health check.
Well, I mean, the health check or nothing about containerization makes the assumption that you're running on Kubernetes. And if you require the application, when it recognizes that the volume is unhealthy, to do a Kubernetes specific action, then I think that's an assumption. That's breaking portability. We don't want to do that.
You have to have utilities on every pod or on every container. You're going to have permissions to.
Yeah.
True, but you said this is a stateful set. Stateful set is a Kubernetes concept.
Right, but your application is not necessarily going to be running through, your containerized application may not be running through a stateful set, right? It could be running on.
Then I'm saying I'm not sure we have. Figuring out this count is a problem. We'll eventually run into that, and we need a common mechanism of surfacing that.
I think like a general principle in Kubernetes is to meet the users where they are, make them have to do as little work as possible to bring their applications into Kubernetes. What that means is we can't tell them, hey, if you've got your stateful application, keep it as is, containerize it. Oh, by the way, stick in this code that knows how to talk to the API server to be able to tell me that your disk is unhealthy. That's a non-starter.
But like
the API server is already pinging the pod, but as far as it knows, the information it gets back is not fine enough grain to be able to tell you that the disk is unhealthy, right?
Exactly.
Unless you have code inside the application that's going to be responsible for surfacing that, and that requires you to modify.
It's a vendor-specific thing, anyways.
Yeah.
Sometimes, right? I mean, like.
So making the application aware of Kubernetes doesn't sound like a good idea. It's an option, but if we can avoid it, we should avoid it.
Stateful set has no notion of what type of PV it's dealing with. He has no idea whether it's local storage or whether it's some remote persistent storage.
The way these issues will surface
Will be through the application.
that the node is going to say I'm unhealthy, the cluster node.
Could we have a sidecar container? This is the answer to everything. That was a footprint. Yeah.
So actually, if you look at the stateful set for most of these kind of applications, they all actually have sidecar containers.
Yeah.
They have init containers.
Yeah.
To handle the case where I'm going to be a new pod and what am I going to do there.
So if a sidecar container monitors the health of the volume and then the sidecar container contains the logic that's Kubernetes specific to report back.
They're already heavily
Yeah.
That's kind of where
If it's a separate container, I think it's okay. But if we force the application container, that's a bad idea. But I think what it's coming down to is we may be able to decouple these two goals and be able to handle the recovery mechanism that local storage needs from health monitoring in general. And they'll be very closely related, but maybe we could split them into two separate docs that make sure that you look at each other's docs, though, so they end up converging. Okay, it's 3:30. Do we want to continue talking about this, or?
I don't. I feel like my straw man's more straw than man at this point.
I think this is a really useful discussion to have. I think this is the kind of discussion that
when's the candy coming out?
That the face-to-face is designed for. This is like the good old days.
Yeah, this does feel old school. All right, so we're done.
Okay, we're done. Let's take a break. I think everybody's probably tired after that. We'll reconvene at 3:45.